video mirrors the I/O redirection lab quite closely. We start by making our own little playpen in which to create files where we won't disturb anyone. We make a directory and we call it play, and then we cd into the play directory. Now we're going to use the single redirection arrow to take the output of the echo command and put it into a file. Just to refresh our memory, echo 1 will write the string 1 to standard out. Standard out's coming to our terminal. But if we take that same command and redirect standard out to a file called F1, no output comes to the terminal. Where did it go? It went into the file called F1. We do an ls, there's F1, and if we use cat to look at F1, it contains 1. We can do the same thing, or something similar, to put 2 into F2. Now, let's assume we want to create a file called F12 that has 2 lines. We want the first line to be 1 and the second line to be 2. Well, we've seen how to put one line in. That's pretty easy. Echo 1 out to F12. And when we take a look, we see F12 has 1 in it. Now, naively, we might think all we need to do is run the echo command again with 2 sending the output to F12 to get that extra line in F12. But what we see when we look at F12 is that we only have 2 in it. That's because the single redirection arrow creates the file if it doesn't exist, and if it does exist, it truncates it and overwrites it. So the single arrow creates the file with only the output of that one command in it. That's where the double arrow comes in, and the double arrow stands for append. And when we use the append arrow, the file's created if it doesn't exist, but if it does exist, we append to it. So let's put 1 into our file again. And this time we say 2 redirection arrows out to F12. And I'm going to bet that now F12 contains 2 lines. Well, that's all well and good. But what about errors? We've talked about standard out. What about standard error? Let's clear our screen and find a way to get an error. If we say ls and a file that does not exist, you can't find me, we get an error. Comes to the screen, and right now it's really hard to tell that this didn't come to standard out. But we can see that it didn't come to standard out because if we send standard out to ls.out, we still get the error to the screen. But if we take the error by saying to redirect to ls.err, well, nothing comes to the screen, and I'm going to bet that ls.err contains that error message. Right? 2 indicates standard error. Remember, there are 3 streams: standard in, standard out, and standard error. And we start counting at 0 because we're computer people. So in is 0, out is 1, and 2 is standard error. We should also at this point have a look at a useful magic file on the Unix system called dev-null. Dev-null ignores anything written to it. So no matter what I write to dev-null, it simply disappears. It doesn't fill up. It doesn't run out of space. It doesn't go to the hard drive. The computer system just throws anything written to dev-null away. Well, that doesn't sound all that useful, at least not at first blush, but it is very useful. We list file 1, file 2, and you can't find me. I get a mix of good output and bad output. I have an error saying you can't find me doesn't exist. And then I get the good output for F1 and F2. Well, what if I want to just ignore the error? I'm only concerned about the good output. I can take that same command and take the errors and send them to dev null. The errors disappear, and I only get the good output. Let's try a real-world example. We're going to search the entire file system for any files named password. But because we're a regular user and not the administrator, there are a number of spots on the file system we're not allowed to look. And the find command is going to say, hey, I'm sorry, can't look there. So I'm going to have a lot of errors mixed in with my good output. But let's see how that looks. Find, start searching at the root for files named password. And I have some good output mixed in with a whole bunch of permission denied errors. This is a little confusing for me. I know I'm going to have a lot of permission denied errors. I just want to see the password files that I have access to. So I'm going to rerun the command, clear my screen, and I'll rerun it, sending all the errors to dev null. And there we have the password files that I have access to. Well, let's take a look at a bit of a stupid Unix trick. Actually, it's a bit more of a cat trick than a Unix trick. If we use the cat command without any arguments, it doesn't read from a file, it reads from standard in. And remember, standard in is our keyboard. So anything we type is read by the cat command and then written to standard out. So we see the line once when we're writing it into standard in, and we see it a second time when cat sends it out. Now, I think I've sort of got myself stuck. How do I get out of here? I could say Control C to interrupt the cat command, or I could tell cat that I'm through sending input to it. And the way I do that is to send cat the end of file character. And the end of file character is Control D. So there we go. Now, what if I wanted to use cat as a quick way to create a file? So cat, send the output to F5, line 1, line 2, 3, 4, 5, line 6, and Control D to say I'm done. Now, F5 should have everything I typed. There you have it. A real quick way to create a file. This can be very useful if you want to cut and paste to create files. Now it's your turn.